Good morning. Let's talk today on something called potential. We mean here the electric potential. So, the potential word is virtually literally meaning a capability to do a work. So, if we say here the electric potential, that means a potential, electric potential amounts to saying that the field has got capability to do a work. And what does this mean? It means uh, if I have got a charged particle Q and there exists an electric field E, so to move the charge, I need to have the force acting on this charge is Q into E, right? And it's along the direction of the electric field. So if we say that this electric field has got a potential to do a work. That means if I leave the charge, this will move away. And let's say it moves away by a distance delta x, right? So the work done is equal to F dot dx, all right? And this work is at the cost of the stored potential V. And where was it stored? It was stored in the electric field. How does the electric field was generated? We know that if you have a charged particle, any charge, this will have an electric field all around it. Say if it is a positive, in that case, this will be going outside. And if you have a negative, so in that case, the electric field will be merging towards it, right? So when we say that, well, I have got a existing electric field E, as we have said here, that means there was a charge somewhere and that created electric field. And the question, what we are talking here is if I leave it here, then this will result into a work done. So whenever how does the work has been done is by the movement of the charge. Now there is a concept, what we call it. Naturally, it would take some time. Let us say t is the time taken to move from time. That's the time in which, or let's say dt is the time in which it has moved by a distance delta x. So what we are saying is uh, the electric field force is q into e, and the work done is f dx, all right? So that's your dx. And If I say, let it be the charge be a uniformly a array of, or is a mixture of lot of charges. In that case, what we say is, or even if it is one, rate at which the charge is moving is dq by dt is called the current. So if I can measure the current, which is the flow of the charges, so from here I can find q equals integral of I dt. In that case, what we have is V is equal to uh, Q E into delta X, and this is in fact is I dt E dx. So without going into this, the total derivation and the relation, what we say here is the amount of the work done or the potential is a function of current. If I have got a conductor, I'm sorry, if I have got a conductor and it has got a resistance R, by Ohm's law we know V equals IR. That's the relation. We normally know it by the Ohm's law. So in this case, this functional relationship is IR. So when we say, if I have got a potential to do a work, right, or the electric potential, that means I have got a capability to move the charge or capability to force a current. If I have got a lot of charges and they are moving with respect to time. So what does the electric potential is also called the voltage, and that's what we say voltage is proportional to current. That's your Ohm's law. So what is the cause? If we talk about the cause and relation, in that case, let me rub it off. Let me go back again. All right. So the cause and effect. If I do the analysis in this way, so the cause is the voltage and the effect is the current. So I have got a voltage, that means a potential to do a work, and this has caused the charge to move, and that's the current. So this has to be always remembered in electrical engineering is a voltage, when we say it's amount to say the same thing as potential or the electric potential, and the effect is the current. So let's take an example. Now, uh, coming to the electrical engineering, the current is the flow of the charges. So if I take a simple circuit here, where there is a voltage source. Now we are saying here a voltage source. So what does it mean is that's a source which has got capability to generate a voltage or has got a potential of creating an electric field in a material. The material over here is a resistance. So that's your resistance, maybe a conductor of some size, right? So when we have got a circuit, it amounts to tell that we have got a capability to generate an electric field across this resistance, which is basically a piece of conductor, or conductor is basically a material which can conduct. And when we say material which can conduct, means there are free electrons, and these free electrons, when being exposed to electric field, will result into a movement of the charges, that is electrons, and that will result into the current. Right. Now the question is, if you move these charges or the electrons from one point to another, in that case, at the boundary of the conductor, where does it go? Does it go to the space? No. So it goes back to the source. So from source, there are amount of charges which comes out. It goes to the conductor and then it returns back to this. If I remove the connection, let's say if I open it across here, in that case, it has got capability, but you cannot push the electrons to the conductor, and so it can't come back. So if I have got a circuit which is like this, that's open, there won't be any current, although there exists a resistance and there is a voltage. Let's take another example. Let's say a transmission line, a three-phase transmission line. So they have got voltages V1, V2, V3. Each one of them have got the voltages. Now let's say if a body is sitting here right on the top of one of the conductors. Now, since that's a conductor, so it is amount to be telling that I have got a resistance. So the two circuits are almost equivalent. There's no difference between these two because I do not have any return path. I can force electrons to go up to this point, but then I do not have anything to come back. And so, if I ask you what is the current in this, it will be the same thing what the current over here. And we say that the current over here is zero, so in that case, this current over here is also zero. So, the bird, although sitting over here, is getting no current through it. Since there is no current, so it doesn't get a shock. So, what is a shock first? When the current passes through the body, let's say a human, right? So the current goes to the earth and then it comes back. Here is your source. So the current passes through this, right? The electrons have got a movement. So electrons, once they start moving in the body, the chemical balance inside the body changes, and so we get a shock. This effect is called a shock. So same is true the word, or if I say a man is hanging from here, right? In that case, the same phenomena is going to happen. he is not going to get a shock till he touches the earth. Right. So that's the basic concept of the electrical engineering in perspective to the one where we talk about the physics from the charges to the electrical engineering where we have got the voltages or electric potential. That's your cause. Effect is the current, which is the flow of electrons in the circuit. So this is all together that makes the beginning of the electrical engineering. Thank you.